Thank you. Thanks to folks at CIPHER for putting this excellent conference on while I still have a job before Michael takes it away with his coding. Today I'm going to kind of continue some of the conversations we had yesterday about measurement error. I was really excited to see so many people talk about measurement error yesterday. Usually when I come to these kind of things, we're really focusing a lot on the errors of representation side of panel work, which is appropriate. It's complicated and difficult, and we've all done a lot of work on it. But as a few people pointed out yesterday, I think it's important for us to start shifting our focus to really think about how different panels and the people and the methodologies behind those panels, the measurement properties of those people and panels. So I'm specifically going to be talking in the context of combining, combining data from multiple panels, and that's kind of a newish thing we're doing at NCHS. So, why combine data? I think the reason we're typically doing it is, in the end, we're trying to get less biased estimates, right? We're trying to get better estimates, and the idea is if we can combine multiple samples, we can do that. And in other use cases, we're trying to target samples or target specific groups. And so to do this, we're going to take data from panel A and panel B and put them together and do the analysis. As I mentioned, most of the research in this area is focused on the sampling side, right? And how do we quantify the change in bias and variance when we combine this data? What are the various approaches to calibrating, weighting data, et cetera. And then what John actually talked about in the last session, right, is how do we mix opt-in and probability data. So that's all incredibly good, important research, but I think less explored has been the measurement differences between panels. And in my mind, there's kind of two properties that we can look at. The first is how do different modes or presentation styles or whatever that are inherent to the panels, how do they affect survey research? So that's kind of the methodological side of, or the method-based side of measurement error. And the other is, do different panels have different quality respondents? And I think the clearest way to look at this is between probability panels and opt-in panels. And we've talked a lot about this over the last day. I'm pretty sure, Andrew, not to preview, but I imagine you're going to have some thoughts about this in a little bit. And coming straight out, I think we, in my program at NCHS, we expect that opt-in panelists are kind of not high quality. The risk is that we know in this room more and more people are using these data to make decisions. In my world specifically, we want to use opt-in data to capture qualitative information about question response, right? I'm a question evaluator, so I like to use opt-in panel data to collect qualitative information. If those respondents aren't high quality, if they have a completely different way of answering questions than people in probability panels, am I actually going to get good question evaluation results? So I'm going to talk, I think I'm only going to do one case study today, just knowing how quick all these presentations have been. So I'm going to focus on our Research and Development Survey, or RANDS, which is a program we started about a decade ago at NCHS. We use probability panels to conduct methodological research, both looking at the properties of panels and how we can use them in the federal statistical system, and then also using these panels for question evaluation research. Over the lifetime of the panel, we've used both the Gallup panel and NORC, and the data I'll talk about today comes from NORC. The other program that I'm probably won't have time to talk about, that Jim will be talking about in I think in the next session, is our rapid survey system. So we'll hold that off, and Jim can, yeah, I think it might actually be your slide. So, okay, so the the case study here is one of our most recent rounds of RANs 8s. We fielded it last July. As I mentioned, this comes from Amerispeak, and the primary panel that we use was Amerispeak. But in this case, and in actually the last couple of rounds of RANs, we've been supplementing our probability panel with an additional opt-in sample in an effort to target specific groups. In this case, we had a bunch of research questions on gender identity. We're exploring how to best measure gender identity. And so we use that opt-in panel to basically oversample people with gender minority individuals so that we could do more evaluation of their responses. So we have the Amerispeak sample, and then we have two opt-in panels here, Lucid, which is a general population one, and this community marketing and insights panel, which is actually an LGBT specific opt-in panel. The questionnaire itself was omnibus, pretty wide ranging, discrimination, emotional well-being, gender identity, disability, things like that, and health. So I'm going to focus on two different scales, psychometric scales that we ran in RANS 8. First, we did a 5-item version of the Everyday Discrimination Scale, or the EDS. And I also ran the 3-item UCLA Loneliness Scale relating to our loneliness work yesterday. Additionally, after the discrimination scale, we asked a couple web probes, and I'll go over that data as well. So what I'm going to talk about today is a mixed method analysis, looking at the difference in measurement properties between the two types of panels. Did measurement invariance with confirmatory factor analysis, and then some qualitative and descriptive analysis of the web probes. So for the everyday discrimination scale, we use, this is 5 items of the larger EDS, and we actually have a slightly different answer category than it's typically used, where matching was used on the National Health Interview Survey, based on some previous research we did. The point of the EDS is to measure perceived discrimination, and the literature indicates it's a single factor solution, and we did a confirmatory factor analysis, and we found that is acceptable. And UCLA loneliness is a 3-item scale and 1 factor as well. So for both of the invariance tests I'm going to show, I looked both across panel types, so Amerispeak versus the opt-in, and just kind of to expand it a little bit, I looked at mode as well within the Amerispeak sample, because we both have web and CAT. The takeaway here is that we did not find invariance across the panel types. For both UCLA loneliness, so here's panel type, we don't have metric invariance, nor for mode within Amerispeak, which is a little surprising for us. And then here is the everyday discrimination scale, and we see the same thing, where we don't find invariance across the panel types. Moving on to the non-psychometric approaches, I had 2 probes. One was an open-ended text probe. We have developed a large language model-based approach to actually qualify the quality of data of our open-ended text. It's called our SANS model. It's available on the NCHS website. And basically, we put in text data and we get out one of these codes, whether or not the data was blank or missing, gibberish, uncertain, explicit refusal, invalid, or a valid response. And what we find is that the opt-in data, with the exception of the blank and missing, tends to have more bad quality data than the Amerispeak. And we can actually go down to that final row there where the valid response. We see there are more valid responses on the Amerispeak than the opt-in. This is what we're expecting, but it's nice to start being able to quantify this. And then the next probe, and I'll end on this, the next probe was actually asking people about what they're actually interpreting the everyday discrimination scale. There's no right or wrong here. But we do see that there's a difference in interpretation, so in what the actual scale is measuring across the two panel types. So we can see that Amerispeak is people say they're responding about racism more, whereas in the opt-in they were choosing the other types of codes. And so in conclusion, skip through the other case study that I'm not even talking about. Back, I can't even go back. There we go. Representation is obviously important, but I think it's, as we talked about the last couple of days, important to really turn to measurement differences as well and start exploring what it means when we're collecting data across different panels, and can we actually combine them? Does it make sense? And what kind of adjustments, that like what Dina brought up yesterday, do we have to make to make that a better a fit across panels? And so thank you so much.